Welcome to SOLIDWORKS to the Engineering Design Process, Lesson 5, Section 3, Part 1. In this section, you'll use Simulation Express to conduct stress analysis on the wing arm of the windmill assembly. Begin by opening the part called Wing Arm. Under the Evaluate tab, click Simulation Express Analysis Wizard to open it in the task pane. Click Options to set the unit system. Select SI for the metric system and IPS for imperial. For this video, IPS will be used. Select Show Annotation for maximum and minimum in the result plots, then click OK. Click Next to start the Simulation Express wizard. The first thing you need to specify is the fixtures. When you select a face on your part to be a fixture, it will remain stationary even when loads are applied. Click Add a Fixture. Select this face, and then click the green check mark. You will now apply a load to the part. Click Next to proceed to this step. To simulate loading on your part, you'll apply forces, pressure, or both. In this video, only a force will be applied, so click Add a Force. Select this face and ensure that the force is applied normal to this surface. The only thing left to do now is to specify the magnitude of the force. Type 20 and click the green check mark to exit the Property Manager. If you want to add a pressure load, click Add a Pressure. The only difference between a force and a pressure is that a pressure is a force per unit area and a force is a push or pull at a certain point. Click Next to proceed. In this step, you need to assign a material to your part if you have not already done so. Click Choose a Material, expand the Steel category, and select Alloy Steel. Click Apply, and then Close. At this point, you've specified the fixtures, the loads, and the material. Click Next to set up and then run the simulation. Before you click Run Simulation, click Change Settings to configure the mesh density. To prepare the model for analysis, SOLIDWORKS subdivides the surface of the model into a finite number of pieces called elements. This is referred to as the mesh. Click Change Mesh Density, and the Mesh Property Manager appears. Select the density of the mesh by dragging this slider. In general, a finer mesh density gives more accurate results, but requires more computer resources and time. Simulation Express suggests a mesh density between coarse and fine. You should use this mesh density for your initial run and change it later to observe the effects. Click the green check mark to exit the Property Manager, and the mesh will appear on your part. Click Next in the Simulation Express task pane, and then click Run Simulation. The animation of the deformation appears in the graphics area. Click Yes, Continue to view the results. The minimum factor of safety is listed as approximately 1.4. This means the model will not fail under the load you specified earlier. A factor of safety greater than 1 at the bottom location indicates that the material at the location has not yet yielded. The material at a location will start to yield if you apply new loads equal to the current loads multiplied by the resulting factor of safety. In this case, to determine the force which will cause the part to yield, multiply the current force, 20 pounds, by the minimum factor of safety, 1.4. This equals 28 pounds. So if approximately 28 pounds of force is applied to this part, the minimum factor of safety will equal 1. Meaning the part is about to yield at the critical region. You will now change the element size and observe the effects on the results. In other words, you're going to change the mesh density. Click Run at the top of the Simulation Express task pane and click Change Settings, and then click Change Mesh Density. A warning informs you that remeshing will delete the current results. Click OK to close the warning. The Mesh Property Manager appears. Move the Mesh Density slider to the rightmost position. Remember, a fine mesh density gives the most accurate results. Click the green check mark to exit the Property Manager, and the mesh will appear on your part. Click Next in the Simulation Express task pane, and then click Run Simulation. The minimum factor of safety is now approximately 1.8 compared to 1.4 before. When loads are applied to a body, the body tries to absorb its effects by developing internal forces. However, these internal forces vary from one point to another. In Simulation Express, you view a stress quantity called the equivalent stress, or von Mises stress. An equivalent stress value does not give you the forces on the part at every point. It gives you a number which reveals the overall safety of the design. To view an equivalent stress plot for the windmill arm, click Show von Mises stress. The stress plot is generated on the deformed shape. Annotations for the maximum and minimum von Mises stress appear because they were selected on the options earlier. You can now run the simulation with the stress plot visible by clicking Play Animation. This allows you to analyze the yield strength at different points of the part when the load is applied. A resultant displacement plot allows you to easily analyze the flex experienced by your part when loads are applied. To view the displacement plot, click Show Displacement in the Simulation Express task pane. The color legend changes to resultant displacement, and you can click Play Animation to animate the displacement of your part when a load is applied. SOLIDWORKS allows you to create a report of the simulation properties and the results. It will save your results as an HTML file to ensure that your information is documented for future reference. Click Done Viewing Results and then Generate HTML Report. The report will open in your default web browser. The location of the report is specified under File Information. This report also contains information about your part's material, load, and restraint information, as well as the study properties. Section 5 is where the results are located. The report includes the results from the stress simulation, the displacement simulation, as well as deformation and factor of safety. Close the Simulation Express and you are prompted to save the Simulation Express data. Click Yes to save so that when you reopen the part and run Simulation Express, the data from this simulation session will be available. In this section, you learned how to use Simulation Express to conduct stress analysis on the wing arm from the windmill assembly. You used the analysis data to calculate the maximum force that can safely be applied to your part. You also viewed the stress and displacement plot, then generated a report to summarize your findings.